to the general contractor, the building owner, to the building department, to the regulatory agencies, to the lawyers, right? The lawyers get involved. I mean, that's where the process breaks down, is in that handoff. So we have to work with each other and teach each other what we need to do to be able to do the whole process more efficiently. Digital workflows from beginning to end of a construction project.
And maybe you think about not sealing your insulating glass units. Do you have external desiccation? Do you have air flowing, active air flowing with desiccation through them? So basically you can easily take each pane away without having to try and scrape all the sealant off. Easily recyclable, easily replaceable.
All right, welcome back, the two of you. We're on the second season of the podcast, and debuting it with two repeat guests. I'll say two legends in the industry, but two well-known guests. And I like to sort of start it off with maybe a thought pattern that's been going on through my head, and this stems from Mick, what we were talking about last week. And really, a lot of this podcast and the theme is around educating the market, not only what we want to push, but from a sort of eliminating any motives or incentives, but what we're seeing in the market. And I think I'm interested to hear what your experience was like when you were with Enclose, because there's a lot of what I want to promote and push in the market, but also as I am on the contracting and manufacturing side, there is an element of what are you selling and what do you have to sell to the market? What's the market ready to receive? And a perfect example is I'm working on a dorm project where we were going to sell our standard multi-lock hardware. It gives you a nice compression seal around the perimeter of the window and adequate what we would think air and water tightness. But the spec calls for a residential grade roto operator, which maybe you'll give you 6 pounds of pressure in the field. And I know that's going to be very troublesome hardware down the line for their facilities folks. I'm not going to name the specific institution, but the question is, do you want to sell what you know is right for the building and right for the project, or are you going to sell what's going to get you the job? And that conflict is one that I struggle with a lot. So what do you first think of when you recall back to having, I'm sure you've experienced that time and time again.
Yeah, well, so my first company, which was acquired by Enclose, was a company called ASI, Advanced Structures Incorporated. And we very deliberately stayed as far away from products as we could, offering custom solutions to the industry, to architectural firms, to builders. And it was exactly, I mean, we marketed what you just said. We marketed that we had no product axe to grind, that we are there to provide custom solutions to their particular problems. And that was, that was very compelling, to a lot of people out there in the industry, a lot of architects especially. It also got us in a lot of trouble because we were constantly doing things that we'd never done before, and in a lot of cases nobody'd ever done before. And we ran that company for 16 years before it was acquired by Enclose. And there were times, especially towards the end of that 16-year run, where I really wish we had products to sell, because they're much sort of easier to build a predictable company around than just selling custom solutions. But Enclose is also a custom solutions provider, right? I mean, they don't have off-the-shelf product, and this was something that I also really Enclose was a really good fit, for ASI to be merged into an organization, because they were really offering custom solutions to enclosure problems. They had a technique that they used that was consistent from one project to the next, but the solution was tailored to the particular building project, right? So it's not that that a solutions company is different than a product company, or better or worse or anything else. I mean, I have a lot of appreciation. Enclose used a lot of products, right? And so did ASI. We used products all the time, and products were important to us. But it's a different business. It's not a widget business. And I wouldn't necessarily recommend it to anybody, but we had a good time.
Well, yeah, and I think the reality is if you're a solution-oriented company, you're going to be limited in terms of how much you could scale or grow, and in turn, how much true impact you could have on the industry. You're going to touch a little small pie, but that's only so much. And Helen, you've obviously you've always sort of been at the cutting edge of innovation, starting with dynamic glass, and now you're on the thermal break side, and but you see the wide spectrum of all of it. So I guess to reframe that question, like who who really is responsible for educating the market? I mean, I think you have the contractors and you have people, the loudest people are those that are trying to sell and get their products out to the market. It's not the consultants and the architects that are actually making these decisions and pushing the final decisions to the owner that are out there really outspoken. So how do we change that paradigm?
That's really interesting. Interesting question. I know Mick will probably remember the some of the results of the research that we just did at FTI on the barriers to adoption of high performance facades. One of the things that came back through the conversations with everyone from the value chain was education, 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 and not just for the architects, but for all the way through the value chain to contractors, subcontractors, code officials, the owners. There's an educational requirement for everyone down along that value chain to be educated through a different lens. They don't need to know like the details about the closure mechanism they just talked about, but for sure architects and owners need to understand that. But yeah, so I think the responsibility is on everyone to educate in the market, for manufacturers, for the fenestration industry. I mean, it seems like the example that you just gave. I wonder if the person specifying that rotary hardware actually knew what they were specifying. I mean, they knew they were specifying rotary hardware, but did they know the options? Did they know the performance requirements or the needs? And it sounds like maybe they didn't, because if they did, they would have specified something else.
It's a standard spec, and I think people pick and choose which part of the specs they want to live and die by versus what's going to be overlooked. I'll give you another example, and I don't want to implicate myself or any others, but it's funny, we're we're dissecting a spec and we're about to submit our final bid on the project, and it's Spencer, of course, and he's like, you can't ignore condensation resistance factor, and he's all over that. But then he's like, but also look at the acoustic value. And I was like, no, they're not going to pay attention to acoustics. And I'm like, if you think about what I just said, like, oh, this one value is important because a facade consultant's going to pay attention to it. But in this area or this building type, they usually don't pay attention to acoustics. So now all of a sudden we're picking and choosing which portions of the spec we're going to take seriously.
Mm-hmm. Yep.
So it's anyway, that's one rant. So the next topic I'll bring up, and I was listening to you give a presentation, Mick, and the other thought of this is the whole double glazed, triple glazed idea. And I think you claimed that in order to go from double glazing to triple glazing, the embodied energy in that third pane will be offset by 20 years of operational energy. And so in essence, you're better off going double glazed. The triple glazing, you're incurring more embodied carbon debt in going that route, that it's not beneficial. So is that my responsibility as a contractor to come forward and present double glazing instead, or is it the design communities?
Well, first of all, that was a study that was done by Circular Ecology at some point in the UK. And there's a good paper out of the University of Toronto that that looks at that not looks at that particular study, but looks at this issue and refutes it. So I don't think that there's. I mean, I certainly don't want to be in the position of denigrating triple glazing. I think it's a pretty important tool, probably a tool that should be employed much more widely in the U.S. But the key thing there, the important thing there, is that what we've done in the past, and to take it out of the context of double glazing versus triple glazing, look at the whole double skin phenomenon, which went on for a while, in the US, still happening quite a bit in the UK. And, these dual skin facade systems, some of them which were very elaborate. All of that stuff was done in the context of minimizing operational energy, right? That was it. We were totally ignoring the embodied carbon, right? And this is part of a single equation, right? Operational carbon plus embodied carbon equal whole building life cycle carbon, right? And we did as an industry, as a standard practice, not consider that embodied carbon. We just left that out of the formula altogether, and we're making decisions based on the energy or emissions from operational stuff, right? Not the embodied stuff. And that's that was a very short-sighted practice. So now we've recognized the importance of embodied carbon. We're considering both things. So this again is an education thing, right? And we need to be educating each other. It's not like industry needs to educate architects or whatever. Like look at something like process is really important too, right? And a lot of the companies, the leading firms, I know this from Enclose, has looked at their internal procedures, right, and has really dialed them in and made them very efficient. And digital workflows in particular is a great example, right? So they've got the digital workflows from beginning to end of their work really dialed in, and a lot of firms have done that. Where it breaks down is between the firms, right? And so you don't see, we're still not taking our digital models, our BIM models, and using those as our construction documents as an industry. And everybody points the fingers at our industry, talking about how backward we are and all this kind of stuff. Well, where it breaks down is in the handoff, right? And that handoff, I'm talking about from the fabricator to the facade contractor, the facade contractor to the general contractor, the building owner, to the building department, to the regulatory agencies, to the lawyers, right? The lawyers get involved. I mean, that's where the process breaks down, is in that handoff. So we have to work with each other and teach each other what we need to do to be able to do the whole process more efficiently. Digital workflows from beginning to end of a construction project.
Well, I think a lot about in 10 years from right now, if I'm going to look back at these videos and think, what the hell were you saying? Or if I'm going to be spewing the same, thoughts or remarks. And this talk you were giving in Shanghai, I think it was 2014 or 2016, and you were talking about the whole notion about us being net zero by 2050, and if it's too aggressive, but it's at least leading us in the right direction, and the challenge of new build versus retrofit. I don't know what your whole thought on the net zero concept is, and if you think we're even sort of trending in that right direction. But I will say, and I'm going to steer this to Helen, which you probably have a really strong grasp on, the benefit of being able to operate in a lot of different markets is that I get to hear these different perspectives. And so I see what's going on in Boston, and I see what's going on in Seattle with their very stringent codes. For the first time in California, and I don't know if this is Title 24 related, but I was listening to an architect talk to the mechanical engineer and basically say, it's the first time I heard that we can offset our envelope with a better performing mechanical, even though they were going the prescriptive route. I don't know what percentage, usually it's something like 10% worse than code, but in essence, they basically said we can't perform lesser than this value. So they weren't going whole building energy model approach, but they were still constrained to certain values worse than prescriptive. So do you think Title 24 has been effective with that? And is it getting us towards this net zero concept?
What I understand Title 24 did this last time is they put a minimum, a worst possible U factor for fenestration in there, like a real, and it wasn't a particularly stringent value either. I mean,
the real driver really was solar heat gain in this instance.
Oh, okay. That I'm not familiar with there being a backstop for solar heat gain coefficient, but I'm not so familiar with Title 24. I certainly know that in Massachusetts, in Boston, which is an amazing thing, is the envelope consultants are actually at the table very early on with the HVAC consultants, which is amazing, so that we get really good collaboration and having an envelope first approach, because you can't get there with HVAC anymore because of the requirements for the envelope. So a lot of the increased stringency at the envelope, you see it with an envelope backstop in Seattle and also Washington, and it's not quite a backstop, but it's certainly an envelope first approach in Vancouver and BC, is that it requires you to really think about a high performing envelope, and you just can't trade off a great HVAC system, efficient hot water and lighting system for a poorer envelope. So that's really moving the design.
It sounds like these codes are at least tackling the operational side, and maybe some of these other markets are going to start copying a Toronto. You might see it in Chicago, or as we go down in the climate zones. But how are we even addressing the embodied side, and how does that play into the whole net zero concept that you were once dreaming up of, Mick?
Well, I mean, I think it varies project to project. I mean, when we used to talk about net zero, it was net zero energy, right? So it was a lot of times as a practice did not include embodied carbon. And now we're talking about emissions, first of all, which is the right metric, right? It's, that's what the real concern is. So you want net zero emissions. I'm not sure myself that we really have the metrics, much less the know-how to really achieve this. But it's definitely what we've all got to be aiming at, right? It's again, it's that educational thing. We'll learn as we go. We got to teach each other, what this is about and how to get there. But yeah, it's got to include the embodied carbon component. That's for sure, and it's got to include the building life cycle.
And so I think some jurisdictions are starting to bring embodied energy or embodied carbon into their codes. Vancouver is starting to think about embodied carbon. There's the Buy Clean Acts coming out of various states. I just saw that Cal Green has an embodied carbon piece to it. So slowly jurisdictions are bringing in some additional requirements to embodied carbon to balance the operational carbon. But, I think when you're trying to get to net zero, it really is location dependent. I mean, if you're up in the Pacific Northwest where your electricity is already really green, electrifying your building really gets your operational carbon really, really low anyway. So then you really got to focus on an embodied. However, you still can't ignore the operational carbon, because when the electricity goes off, you need a high-performing envelope to make sure people don't die in, a heat wave or a cold snap. But if you think about, where I'm located in Ohio, we have a very fossil fuel-driven grid, and so it's really important to get the operational efficiencies dialed in, and then also think about embodied carbon. So, it really have to, I think, part of doing, as Mick said, it's really important to do a life cycle assessment, because you've got to understand the balance of upfront carbon and operational carbon. And then there's this big, I guess, elephant in the room that nobody really wants to talk about, is system lifetime. Because, when you think about embodied carbon, it really should be, and this is not, this was an epiphany I had when talking to an architect, a friend of mine, who basically said you really should be measuring embodied carbon per year of service life, because you can have low embodied carbon of systems. You can dematerialize systems to get embodied carbon out, but if they last half the time, then it's not a good trade-off.
Yeah, absolutely. Yeah, if you double the service life, you basically halved the embodied carbon of life cycle footprint.
Where does importing overseas material play into this, especially in the embodied side of things? And I think about this for a few reasons. The whole tariff thing is happening right now, which I don't think many of us can speak on or know how this is all going to play into effect. But B, Mick, when you were telling me about some of the really, really high quality systems and assemblies that you would see coming out of Asia when you spent your time there, if we really shouldn't be shutting out that. And, if you can buy a really high quality assembly from overseas and save money A, what the embodied implications are of that, but B, how you could then spend some of those savings elsewhere, maybe on higher performing glass. I don't know, maybe you then put that extra money into envelope commissioning on site. Like how you can sort of how you're looking holistically at the big picture instead of the individual components.
I mean, it gets complicated. You know, these supply chain issues get very complex. And I mean, I have been involved in building projects where unbelievably glass was bought in Asia, shipped to the US to have a special coating put on it, shipped back to China to be assembled into a curtain wall unit, shipped to the west coast of the United States, and then trucked across the country to be put up on a high-rise building. That's, it's hard to wrap your head around that being any kind of an efficient process, right? But these things get very, very complex. Like you're saying, you're adding to that by saying, well, look, if you can save some money and buy more efficiency here, these get to be very complex problems, right? And I don't, honestly, I'm not, I am suspect of our ability to even calculate these things at this point and truly understand what's happening. I don't think we've got the tools or the metrics to navigate this complexity, which is, again, takes it back to the education thing. We've got to teach each other, what we're doing, learn to do it better.
I think one, from my perspective, just by, I have a relatively narrow view compared to Mick, who's kind of lived this. But if you just want to think about aluminum systems, there's a lot of embodied carbon potentially in aluminum or not, depending on the aluminum source. If you buy aluminum from China, from the Middle East, it's likely been made from a very high intensive, fossil fuel intensive source. So it's going to have a pretty high embodied carbon. If you buy aluminum from sources that use hydropower, like in North America, lots of North American aluminum and European aluminum, you're going to have a much lower embodied carbon. So, those are one of one of the first questions I would ask about, where does your aluminum come from? What fuel source was it used? Because that could be a real big swing on the embodied carbon of your aluminum fenestration system.
Yeah, these are the low-hanging fruit things, right? I mean,
right, exactly.
And recycled content, right? Specifying recycled content of the aluminum. These are low-hanging fruit things that are often not taken advantage of. They're often ignored on building projects when it comes to the specs.
What are you seeing in, because I know, Helen, you like to focus on the edge or the perimeter where the weakness is, whether it's the interface, whether it's the frame, or whether it's the edge of the IGU. I actually found out recently from one of our glass suppliers that they don't like to put argon in spandrel glass because they're afraid of spontaneous breakage. So that was a first, and we had to really haggle them to do that. And shame on us for not doing our due diligence up front. But what are you seeing in the glass world, I'll say? Is warm edge becoming normal? Are you seeing more double coatings? Is argon fill becoming normal?
Yeah, as codes are getting more stringent, I think it's the easiest things to do to make your fenestration system more energy efficient is to put a warm edge spacer in it, put argon in it. And, we see that people would rather stick to a double pane than a triple pane because, then you don't have to change your frame. And so then the next thing that they will do is go for a fourth surface low E. Of course, the easiest thing to do is invest in a higher performance frame, do the warm edge spacer and argon. It's more expensive than the last thing you'll probably do is put a fourth surface low E on. And then, of course, as you know, if you're putting a fourth surface low E on your glass, you just have to be careful with condensation because it can increase the condensation risk, especially if you're in situations that already have high humidity, like, apartment buildings, hospitals, those kind of things. But yeah, I mean, the first thing to do is put a warm edge spacer in. It's easy, tends to be drop in, gives you a U factor improvement, anywhere between 0.2 and 0.5 if you're in structural glazing. So yeah, I see that is that is starting to trickle down further down into the country and into the middle of the country as code adoption as we get into the ICC 2021.
But then, you know, Helen, you talked about durability as an important aspect of this, like life cycle stuff, right? So
yes,
my understanding is that the argon, I'm just, you know, you're more of a glass person than I am, but my understanding is the argon dissipates at like 7% a year or something like that, or, you know,
I don't think it's 7% a year. I mean, I think it's clear that, you know, that the insulating glass unit is not a hermetic seal. But, you know, if you make it right and you have a good design, you can minimize the moisture ingress rate in and the gas loss out. And that's the challenge of making insulating glass well to minimize gas loss. But 7% a year is not a number that I have.
Yeah, don't quote me on
across.
that. I'm not. I looked at this at one point, but it's been a long time ago. I looked at it with Selkowitz. And
yeah, the Europeans, you know, the Europeans would say that, you know, in their seal test, they do an argon loss measurement, and they have a limit of the argon loss after their weathering test of the equivalent of 1% per year.
How effective is the desiccant in the drying out the cavity?
Typically good. I mean, it depends on the spacer system you're using, but typical box spacer that has holes allows the air to move between the cavity and and where the desiccant's held in the spacer. It's effective. I mean, so basically, a unit will fail, i.e., you'll see fogging or corrosion of your low E coating when the desiccant is used up.
Is the idea that once we're aiming for a hermetic seal, yes, it's not perfect, but is the idea that you're going to lose a rate of 2% argon a year, or is it like the first 5 years are going to be ideal, and then once you start losing, it's at an accelerated rate?
No, I mean, I think that's one thing we have to be careful of is the design of an insulating glass unit is not a hermetic seal. It's not. I mean, I know I see that a lot in specifications, but we're not making a hermetic seal because we know that the sealants have a non-zero moisture vapor transmission rate. So there's no way, even in a perfect design, is it hermetic. So the idea is to, you know, make sure you have a good design, make sure you make it well, make sure you install it well to basically minimize the moisture ingress.
What does make it well mean? How do you test for quality?
Well, that's a very good question. I mean, you've got to have quality controls in your manufacturing, and part of that's in your design is you have a design for manufacturing so that you know that you can manufacture it consistently. And that variations in manufacturing, the design is, I guess, robust to variations in manufacturing, and that you have a good control plan. You know, and this is one of the reasons why in North America we have insulating glass certification, because it's not enough to prove that you can make a good unit once and have it pass the test. We like to, you know, basically continue to have to prove to yourself that you can make it and to the market that you can make it well year after year after year. And that's why our certification programs like IGCC, IGMAC have regular audits, and they come and watch the manufacturer build their units and they test them regularly to ASTM E2190.
Do you think the quality control or internal testing on triple glazing should be more stringent than double, just given now you're introducing another cavity, another perimeter seal, or is it essentially the same process?
I mean, it's the same process, but you're adding in, for a conventional triple pane, you're adding in 2 additional seals. So now you've got 4 seals, not 2 seals. So, you know, you have to make sure that you've got good process control on those seals. And 2 of them you can't see, you can't inspect. So it's even more important that you have good process controls. What I would say for triples is that I think our industry have to get, or should get, used to doing an edge seal stress calculation on our unit, on the units. As you increase the cavity dimension, as you increase light thicknesses, as you go from a double to triple, for a given size, and for a given loading, climate load, you increase the force on the seal that might be pulling the seals apart. So if you think about an insulating glass unit, spandrel, for example, they can get pretty hot, right? And if you've got a well-sealed unit, the unit can go like this when it gets hot, because the increased pressure of the gas, because it got hot, can cause the lights to deflect. And if the lights are stiff, the edge seal moves apart. So for very small units where the lights are quite stiff, instead of going like this, the units pull apart at the seal. So you get a lot more edge extension. So of course, as the seal pulls apart, you've got more surface area for moisture to come through and gas to come out.
It's kind of interesting that people are so afraid of triple glazing, yet, especially new construction here in New York, most of the builds have laminated insulated glass just because of the acoustic requirements here, which in essence is 3 panes of glass. Similar, you would think, weight, but per what you were just talking about, you have 2 lights of glass on, call it the exterior, single light here, and you have that much stress on the perimeter seal. So it's probably, it might be more stress in that
case. It is more
stress
stress when you, so basically you can assume for an edge seal pressure calculation, a triple pane is the equivalent, or the 2 cavities in a triple pane you add together, and it's the equivalent of the same double pane with the combined air gap. So the going from a double to triple for the same size unit increases the edge seal stress. So we have to be quite careful when you go from a 1/2 inch cavity to basically 2 1/2 inch cavities, so 1 inch. That can significantly change the edge seal pressure, and for small units that can get quite large. So we're not used to doing those calculations, but we should probably do more of those as we go to triple pane.
I think one of the most frustrating aspects of this industry when I'm acting as a manufacturer, not a contractor, is I feel like I'm a step removed from the team. And so I can't really communicate what I want to communicate. Everything's got to be funneled through the sub, who's then funneled through the GC. And I've spoken to a few float glass suppliers that are like, I can make my recommendations, but it's up to the fabricator what they want to do. And when you were focusing on spacers, you probably felt even more removed. So like, do you find, and forget these, you know, the high end unitized enclosed projects that you probably worked on, I'm talking your more run-of-the-mill projects. Do you think the IGU fabricators are even like opining on the design and reviewing and approving the conditions that their IGUs are set into, and the stresses that might be imposed, the loads that they might be under? I find that's an area that's often overlooked, and like, you know, your facade consultant reviews it, but the one step is like, has your IGU fabricator reviewed and approved this design for their assembly?
I think some do. Some probably have some good rules about, you know, minimum sizes and cavity dimensions. But I think it would be certainly good practice for them to have line of sight of, you know, how it's going to be used.
How it's blocked around the perimeter, the point stresses it might be under, and especially when you get into the case of spontaneous breakage, which whether everyone wants to deny admit it or not, they've all experienced at one point, and it becomes a finger pointing match. And there's so many factors: thermal stress, you know, extreme conditions during the first winter, breakage, nickel sulfide, all these different things, and there are so many parties who want to chime in on that. But, you know, owner sees it, you know, we have faulty windows, we have faulty glass right away, lawsuit, this, get it out of there, get it this. But that's like such a sensitive area of the industry that requires, you know, we talk about education, Mick, and getting these principles out there, but think about like the true glass experts, not only, you know, in our country, in the world, that like really, really can chime in on this, yet every single building has glass on it. And so it's like, I think there's this, had a glass expert on the podcast who kind of said like, it's sort of simplicity or transparency makes people like think it's not much when it really is this like complex beast in nature that's going to have like very complex behavior over the life cycle. You know, so people look at like beautiful terracotta and this and like, oh, look how intricate it is. But they just look at glass and think like, oh, it's just like, you know, the glass on my shower door or like on my, you know, dining room table. So I don't know, finding a way. I always think if you want to educate people, make it relatable or make it fun or interesting. So somehow like displaying the extremities in our industry and what I don't know what like I'm looking at the World Trade Center right now and like what a true marvel that is when people just look at it and think it's just glass around the skin. But like the real engineering that was required to make that thing last 50 years. And maybe that's what you experience with your students, and that can be inspiring to them.
Yeah, well, I mean, look at the difference. Look at the evolution in fabrication process from float glass, just annealed float glass right off the float line, to what that becomes in a building, today, or in an automobile for that matter, right? You got wires in there that heat up. It's laminated, thin, curved. I mean, all of these kind of things. These products are ultimately highly engineered materials. That's why, when you talk about recycling and reuse, you're really losing a lot. You're not just losing that float glass, right? You're losing all of the engineering that went into, the creation of that, the fabrication of it, those low E coatings, the inner layers, these assemblies, right? They're actually very sophisticated, and yet so that's what makes this issue of durability so important, right? How long they last. I mean, they're amazing, but you look at it from another perspective, and we've taken that annealed float glass, which is good in the building envelope for, Helen knows what I'm going to say here, which is, it's good forever, right? And in doing these highly engineered products, these assemblies, we've made them not only not recyclable, they don't get recycled. We've made them, we've collapsed that durability from, indefinite, down to like a 20 to 30 year time frame, right? And we call it high performance glazing, right? So our performance metrics are incomplete, and if all you got to do is take a parameter, change a parameter, say instead of 20 to 30 years, this glass product has to last not just 20 to 30 years, but it has to last 800 to 1,000 years, right? And don't tell me that we can't design an assembly out of glass that's not going to last for 800 to 1,000 years. We can do that, but it's not going to look like what we have. But I'm
Or
real
maybe
interested in
just
what it would look like,
maybe just making the glass easily replaceable. I mean, I think the other thing you said is like, do we have access to the embeds? Can we leave the embeds in place? So like, at least if the structure can stay in place, and then maybe the next step, if the framing can stay in place, and we have punch windows that can easily be replaced from the inside. So you don't have to swing a scaffold, that it's $50,000 to get the permit and blah, blah, blah. At least like minimizing the damage. So there's going to be a little bit of damage, but relative to what we're working with today, there's so much room for improvement.
Yeah,
Yeah.
and maybe you think about not sealing your insulating glass units. Do you have external desiccation? Do you have air flowing, active air flowing or desiccation through them? So basically you can easily take each pane away without having to try and scrape all the sealant off, easily recyclable, easily replaceable. But as Mick said, it's very, very different to what we're doing now. Do the coatings need to change? Because, can we really create, minus 40 degrees F dew point in that cavity? I don't know. But, there have been one or two examples of, this kind of external desiccation. But clearly it's not it's not been scaled. It's not really scalable at this point. But it does require a big change to how we do things today.
I mean, yeah, you might have to vent the cavity, and
That's right.
And you might have to, there might be maintenance involved, it might mean that over time you're going to get some buildup, accumulated dirt or whatever, and there you have to take it apart and clean it.
Yeah.
And maybe at some point in the future, that's not going to be the burden that it is now. I mean, basically you have maintenance driving a lot of decisions today in building owners. What they want to hear with the curtain wall system is this is a zero maintenance system. And what we're basically saying when we say that, and we're happy to say that in the industry, we're saying this system is good for 20, 30, 35 years, whatever, 50 years maybe, and then it's done. It's over. You got to rip it off and put a new one up because there's no way to maintain it.
Yeah,
Well,
and it's not also like we haven't done ventilated double skin facades before. We know we can ventilate those. So there's some like technology already there and tried out.
Well, we've spoken about this, Helen. It's like, why is it that like you have a guitar or you have a car and there's expected maintenance in that? I mean, even with operable windows, like they're high performance, but if you don't adjust the locking points and the keepers every 6 months, 12 months, 18 months, the performance is going to denigrate. Then they're going to wonder, why do we have whistling? Why do we hear that airflow? So like just setting those expectations early on, get what you're paying for.
Right. And, you know, is there a business opportunity here for facade maintenance? Or I think as the Europeans were thinking of, you know, renting facades or leasing facades back, you know, I'll put a facade on your building, but you don't own it. You just pay me a rental for it. I don't think they ever quite got the numbers to work, if I recall, Mick.
Well, theoretically, you know, depending on who was doing the numbers, theoretically, some of the people got them to work, but they certainly never got it into practice. Nobody stepped forward with a business model for actually implementing that idea. Although I think it certainly has merit. I mean, the conditions today don't really demand it. Right now, so much is based on, you know, these short-term financial calculations, right? It's, you know, that's the basis for you know, for the decision making, short-term costs. And if people are forced to look at buildings and evaluate buildings in terms of life cycle, all of a sudden that starts to make a lot more sense, that leasing strategy.
Well, thank you both for listening to me rant. And because I made you come back on here and do this, I will give you a chance to share the next FTI event or any other event. And I do vow to help promote that next one coming up.
Oh, that's great.
Yeah. Well, it's going to be in New York, so we're right on your doorstep.
I'm coming to LA next month, so I was hoping you guys were going to say LA, but
well, we do have a very active LA chapter.
Yeah, we do have an event happening next month too in LA. But all right, so we have a sort of a heritage forum going on, which you would be more than welcome to come to. I think it's on the 19th of March. You know, McCarthy is sponsoring that at their facilities in downtown LA. It's going to be really an excellent program. But we also, our big program this year is our Vitruvian Honors and Awards program. Helen, you want to talk about that?
Oh, well, it's going to be in New York at Center for Architecture on Tuesday, September 18th. So it'll be we'll have some presentations, and then we'll have a lovely cocktail evening. So it'll be a great networking event, and we'll get to basically celebrate some great architecture. And the one award I really love is the Unsung Hero. I think that was something that you created, right, Mick?
Yeah. Peter Weismantel and myself. Yeah, we came up. We've expanded the program. We've got like, I don't know, 12 or 13 different awards, all facade related. And they vary from, a lot of them are project awards. We have, for the first time this year, we have a student project award. And then we got people awards, the collaboration award and unsung hero. And it's a really cool program. It's open now, right? It's a, you know, it's a submittal format. It's on our website. I think the deadline is sometime in June for
16th of June.
16th of June. Yeah. So yeah, it's a great program, and we've got a great lineup of judges. That's also on the website, and it's going to be a lot of fun.
All right, Facade Tectonics Institute, March, LA, September, New York City. Find it on the website. Bother Mick and Helen all you want, and thank you both for coming on.
Thank you. We look forward to seeing you there in New York.
Of course.
Yeah. Thanks.
Thank you, guys.
Have a good day.